Holy moly, look at that. That's a proud dad moment right there. On this episode, we dive into the 1959 all-wheel drive El-Camino and create a fully functioning pushrod-style bell crank suspension.
3, 2, 1.
Welcome to the Off the Rails YouTube channel. Before we actually dive into building the pushrod style suspension, I want to kind of clarify and show you guys exactly what we're diving into before we get there. Pushrod style suspension is really just a bell crank. This is a lever with two arms with a common fulcrum point that allow you to change angles from the input to the output. Really what this means is, I did everything in circles to kind of make this more simple. Now there's probably a better way to describe most of this, and there's probably guys out there who are way smarter than I am that do this for a living. But this is how I actually figured out mine. We're gonna get more into this later on in the video, but the bell crank is really gonna be this piece here. I drew a circle because it was the easiest way for me to understand what I was doing when it came to designing this. Really what we have is the drive force angle, which is the coilover itself. Our input from the lower control arm here. This is our Mentor Motorsports bracket, which I'll show you. And then the output force is on the circular pattern, the drive coming out from here. If you can imagine in this circle, there's always these little flat spots right here. So this would be a 90 bell crank, which you guys have all typically seen in motorsports. There's also a 180 style bell crank. But what we're gonna do in this episode is figure out the math for the drive input to the drive output and figure out how to correlate our lower control arm movement with this upward swing and figure out where on this pivot point we're gonna mount our coilover to come up with the best ratio for us. Long story short, we're gonna figure out all the math, figure out where the input goes, figure out where the output angle goes, and then from there, play around and truly figure out how do we get this wheel bearing to travel at the same rate as our coilover in the chassis. I know it might be confusing with drawing all this, so I actually made a working model, which I really want to show you guys. You think about this. This is a 4-inch circle. And what I have is I have a couple of inputs and outputs. So in our car, we're gonna have an input force being the lower control arm driving this unit, and then an output force going to our coilover itself, which we're gonna mount at a different angle. And what you can see here is we have two examples of typical style bell cranks. This would be a 180 style, and then this would be a 90. So I want to show you this. This is pretty cool. Now, try to imagine these being directly straight. Now for the 90 version, this version right here, which you see in typical motorsports, drive force is directly up, output force is at a 90, which would be the coilover. Now for a 180 style, drive force is up, drive force is back down 180 degrees. This is two basic styles of bell crank design. What we're gonna do is we're gonna find our happy medium, which I believe, just from looking at it, not really doing the math, we're gonna be somewhere over here. Imagine the drive force is up here, and somewhere over here, I imagine, that's where we're gonna be, which we're gonna figure out in the math later on in the episode, because our coilover is going to be driven at something like this. So once we figure out the angle, we will find here on the semicircle where this piece has to go. But again, it's pretty cool. Drive force up, drive force down. There's our bell crank action in work. Magic is later on in this video is when we create this bell crank, we are going to figure out at what angle this driving force is coming out. Now the big thing we have to figure out is I want this bell crank to be a 1-to-1 ratio. Where I mount it on the lower control arm is going to dictate how long this output lever is to my coilover, because it's not a true 1-to-1 down low. My coilover does not get mounted directly to the outside surface of where the bearing is for the wheel. Let's dive in, figure out how we're going to start the base, where we're going to end up, and how this thing comes about. Now, in the last episode, you guys saw that I created the tube structure and I had this bend in it. And I had a little idea. This is how it was going to work. So this structure right here is actually going to be the pocket for the coilover itself. I didn't really explain it too well, but this coilover I feel is going to be right here. Our bracket's going to be right here, and I'm going to dive the pushrod right there.
We have been given the scientific knowledge, the technical abilities, and the materials to pursue the exploration of the universe. To ignore these great resources will be a corruption of a God-given ability.
Beyond that frontier area are uncharted areas of science and space, but I believe that the times require imagination and courage and perseverance.
So this is what I'm thinking. Off camera, I put the CV joint in, or a test one that I got from the drive shaft shop in, and I had probably as far as I could possibly go, right about here. So I made myself an index mark. I also made a mark where my anti-roll bar or torsion bar lined up, so I have a hole here. So I have some parameters I have to hit. I have to get this here. It has to be able to swivel. It has to be able to miss this bolt. I have to have this one here. This one here will be easy. This will be pretty easy too. I'm just gonna come up with some sort of design. So I'm gonna take off the measurements from this faceplate here, go down, give myself enough room to swivel. I wanna get this thing as low as I possibly can to keep this thing strong and make it into some sort of a design that I could box later on. For this episode, I'm just gonna whip it up, tack it, because I have a feeling I might have to go in here later on and adjust all this and kind of move things around. I'm gonna use this as a spacer so this piece can't collapse. And I'm gonna trim it. We're gonna trim it, come in here, and I'm gonna make some sort of an overhang where this slides through. And it's gonna hold itself up and be offset just like this. So this piece slides on and pops in, and my tabs and slot will just ride this contour right here. So let's go ahead and take our measurements, let's cut some pieces, and we'll go from there. So tune in the old micrometer here. At a lathe. Make this all up, but you gotta work with what you got. Kiss the old girl. This pop together like a little puzzle, and I'm just gonna go like this. Now we have two tabs, lock it in. We also have our pivot point for the Mentor Motorsports piece. So now all I gotta do is I gotta go true it up, square it up, make it look pretty, off camera so I don't bore you, and tack it in. Let's do it. Lower control arm in, and then from there, I only tacked it real light too. I want to be able to adjust this. I don't know where the plane straightforward with this thing is in correlation, so there's gonna be some alignment we have to do. Let's see if I can do this with one hand. These lower control arms are pretty cool, by the way. These are from Part Shop Max. I think you guys have probably seen that before. These are gonna allow me to do a bunch of stuff down the road when it comes to adjustments with my caster camber. All right, let me see if I can do this in one hand too. Looks like my jack jig is not doing too well. Okay. I have a dummy CV joint. This is Corvette style spline that just comes in here. Just gave me an idea with a boot. Where it's gonna be, that's where I kind of came up with the dimension here. So what we're gonna do is, let's get the fork and see how this fork looks. I got a real light tack, so I can't be going crazy. And there it is. Okay, so what we're gonna do is we're gonna take this rod, time joint in the sleeve, we're gonna cut it. What we're gonna do is from there, weld it to a bracket top of the Mentor. This plate, I actually drilled it off screen. This plate bolts to the top of the Mentor, and then from there, Imagine a little piece like this that we're gonna cut, tack together. This is going to be the actual piece that allows movement from the Menser coilover piece to the rocker itself. That's what we're gonna design the end of the rocker off of. So let's take this heim joint, let's get a ballpark approximation how long we want this to be. We'll cut it, tack it, build it, and bolt it on top of that. So what's gonna happen is I wanna get that heim joint to around 4 inches. So 4 inches is our total. I'm just kind of going by this with having the heim joint above the plane here. So it gives us more room to design the rocker, however this is gonna be. I can already tell you this rocker is gonna be pretty big. It's good. Looking at the depth. I went with this area right here because I wanted to get this motion ratio as close as I could to the old Corvette. So I kind of got the lower pivot point close as I can without hitting the CV joint. So that's where I got that from, but even talking about that, we got a big old piece here. My idea was the rocker for the actual, or the bell crank itself was gonna ride off of this plane on this tube, which is gonna be all tied in structurally later on. So I'm looking at that arm, the arm's gonna be almost, one part of it's gonna be almost 9 inches long. This is gonna be a big boy. All right, bang, bang. We got this. Let's mat these up. Let's go ahead and prep this. Clean out the edges a little bit. A little kiss. Then my measurements, this will pop it straight. Now, this will be our unit right here. So let's tack that up. This right on top. All right, we have a home. So now that we have a perch, we'll start playing around. We'll start designing the actual rocker itself. This is where the fun's going to begin, where we get to get creative, but we also have to get very precise. So we are going to do this, and by no means, again, this is going to be a tutorial, but I'm going to explain to you how I got there, how we got there, how this all works, and my theory of how we got there. So if you're watching this and you're a mechanical engineer at NASA and you give me this whole description online, I'm working with what I got, okay? I'm working with what I got. This is how we got there, so let's get there. I went ahead and I already made some tabs for my node here. So this is my theory. This is what I've been dreaming about. So when we started getting all artistic with this, we put in these 2 nodes here, these 2 bend points. These 2 bend points are the weakest part of this tube. This is the area that's most prone to collapse, and it's a very structural piece. So what I think I'm gonna do here is, as I create this system, I'm gonna loosely build all this, get the geometry, but nothing is really built how it's gonna be built later on. I'm gonna take off this geometry, make this a working model, and then from there extrapolate it into something that's real. Real lower pivot points, real tied-in brackets that are all double sheared and welded together, and some sort of a billet piece that's gonna tie these 2 nodes together, get rid of this tube, but this will hold this 2 nodes. And what happens is both coilovers will be fighting and trying to rip themselves apart, but also taking the load of each other. So I will design something later on that will fill this in and hold both coilovers. But for now, off screen, I came up with this. This is where I think aesthetically it's more pleasing. And also a great place to put our coilover. If you think about that, where this coilover is, you can already start to see how big this rocker is going to be. I don't know if you can tell, an imaginary line is our lower pivot point is going to be somewhere on this tube. My bracket's going to be here, tied to this heim joint. This is going to be the driving force. And then from there, this is going to pivot and have to drive this down. Now what I am worried about is I have to make a 1-to-1 ratio. The whole idea is I want this coilover to react like there is no rocker. I want this coilover to react like it was just right here. So when it comes time to tell Mr. Menser about how the car reacts, I can send him, he can change the valve body, not have to worry about any of my ratios. With that being in mind, we have to get a 1-to-1 ratio, 1 inch of compression up, 1 inch of rebound will translate to 1 inches of rebound, 1 inches of compression, and we're gonna set everything somewhere in the middle at 2.75. So now that we have that, let's take some measurements and let's figure out where our plot point for this is going to be, where our pickup point for this is going to be, and where our ride height length is going to be, and then from there, start designing some sort of a template to start playing with our 1-to-1 ratio. So I need to be able to translate my geometry and do this quick, and I want to be able to actually have this thing pivot and be smooth. So this was the idea for this. I bought this years ago. This is like 4-something years. This amazing company built this rocker, which I cannot use for my car because you can obviously tell the stroke and the rebound. I had a different project this was going to go on. It was a lot smaller vehicle where 1-to-1 90 ratio is perfect. What I do want to use is I want to use their bearing surface. So they have 2 bearings that press in here with a locking retainer. I hate to do this because this piece is incredible, but I'm actually going to cut this. What we're going to do is make 2 holes, and we're going to use this as our mating surface to actually help this thing rotate as we go ahead and start designing our rocker itself. So let's go ahead and put this in the bandsaw. We've been using that thing a lot today. Cut this off. I know it sucks. This is a great piece, but we need to, well, we need to move forward, and I think this is the best bet to have myself an articulating surface to be able to move on from. Time lapse! Drilling time. Butcher in a perfectly nice piece. Yeah, that's what we do here. We butcher all the nice stuff. We make custom stuff because we gotta be cool. All right. Here we go. So now we have our cut, drilled, useless piece. But we have 2 bearings, locking retainer in here, which means I don't have to build that. So now we have a pivot point that I can make my tab to that rotates here. So I just cut that piece up to make myself a little something here so we can actually pivot off of. All right, so we're gonna do our first bracket to hold a rocker. So we're just gonna do a 1 5/8 hole. We know that. I'm probably gonna come off 1/4 inch, yada yada. I'll come up 2. This is what I gotta figure. I gotta figure how much depth I need. Up. And then our bolt hole is gonna be 0.46. Okay, so this is a pretty simple. I wanna show you guys the power of QCAD. It's like cardboard design, but on steroids, but it's not exactly Fusion 360 type stuff, you know what I mean? We're like right in the middle there. So what we're gonna do is, we know we need a 1 5/8 circle, 4, 6, directly in the middle, bang, now. All right, what we're gonna do is we're gonna come off here, give ourselves a little bit of spice, go to the tangential, and we're gonna mirror this. And here, let's clear this out, we'll see a bracket come about. Get rid of that, we don't need that, we don't need the line, don't need that, we definitely need the bottom of the 5 5/8, and then boom, there is our bracket. All right, we got our files, let's fire it off and cut it on down. All right, so the whole idea is later on in life when we actually build a real rocker, we'll probably make these again because these are all scratched up. But the tab holds this, it retains against this inside surface with a bearing. This is the thing I was trying to get away from. I didn't want to have to build all this right now for you guys so I could just test my theory. I just wanted to jump ahead a couple steps. This. Boom. So now we have a rocker surface, 2 bolt holes. Self-align this real quick and tighten this up. So now we have a place for us to go ahead and have some fun when it comes off of the tube. As for the angle of the tube, I don't really know what I'm gonna do with the angle. I think I'm just gonna kind of get it somewhere. I don't think I can really make that rocker any shorter. So let's go ahead and get this tester on. And then like I said, later on in life, you can see this, depending on how I make my actual rocker, I'll adjust my bracket to have some sort of a bump stop in it and put all that internally. But for now, I just want to hold this piece up to get my geometry correct. So let's go ahead and tag this in. So now we have a bearing surface. Now we can have some real fun. So now we just gotta play around. So I'll start taking some measurements. Now we're gonna get our instant center, our pivot point, to the rod, and then set our angle, commit, and then from there start building away. So before I even got into this, I wanted to make a way that I can measure this. I was gonna jump the gun and start designing it, but I realized I wanna have a way to measure my height go back and forth. So what I'm gonna do here is, this is a template I made. This is just a bolt pattern on the Corvette stuff. And I put a tab here and a level mark here. So I have myself the same baseline for this little science test that we're gonna have coming up. What we're gonna do is whip this on. This is gonna make me feel better about how we measure this moving forward. We actually have a baseline. We're gonna measure the ride height on the other side and just make that lower control arm the same height, and we're gonna mark it on a big 90-degree ruler I have. I think I could fit one in here, so let's go grab one. I'm gonna put something right here. We're gonna put some tape on it. That way we have a measurement of how this thing travels. Okay, all right, so my thought is, let's get close. See if we can make this work. And then this is gonna be our, let's go a little closer. Now we have ourselves home base. So let's go measure the other control arm, which we know is that ride height because we have the tire on, and then we'll make this one exactly the same and put some tape on it. All right, so off the table, we are 6 1/8. 6 1/8, on that line. Okay, so now that we have our ride height, because we compared it to the other side, this tool that I made comes on here. All I'm gonna do is get a baseline for this little plate that I had. This always kind of gives me a home to go to. Okay, so we're at 0. What we're gonna do is, now that we know where home is for ride height, let's get some handy dandy tape and let's mark home. We're gonna mark our total compression and rebound of that Menser piece. 5 1/4 divided by 2 is 2.625. 2.625. So we're gonna go 4, 3. We have our ride height. We have our 1 inch, and then we have our 2 inches. So we have a total of 4 inches. We have our 0.625. This is the extra amount to get us to total compression and rebound. So theoretically, this is our total stroke travel of the coilover itself. So now that we have a baseline with our tool, we need a baseline for the coilover itself. And I need some way to track movement on the outside, get us in a ballpark, see where we're at. Okay, so once we actually build our first piece, we now have a height up, and then we also have a stroke amount. So our goal is, for this idea, we've kind of beaten to death, is we want to get 1-to-1. So let's start designing. We need a measuring tape. For one thing, that we are going to set this at 10 degrees. So let's get our bolt to bolt here. So let's set this at 10 degrees. So this should be 110. No, it should be 100 degrees to be 10 degrees. You know, the eyelid is the pivot point here. We're gonna start our first one. All right, 7 hole to hole. I got a feeling just from doing this, that coil is gonna have to be more straighter. I don't know, I'm talking on my butt. Let's just cook the first one up and see what it does. So I took some measurements, and you guys saw that I measured the 7 inches. So I went ahead and I just put the bolt hole for our bolt we're gonna test now. And this is where that little piece that we made comes into. So it took some time, and I imported the bracket that we designed, set it at the angle that I actually installed it, because I just installed it. And then from there, I created a center line, and I created those 2 bolt holes here, so we can now have this goofy looking lever. I just kind of whipped this up, and it's not made to look nice. It was made to get this hole to here. I left myself some room so we can adjust these holes later on for the stroke. So let's go ahead, let's cut this, and then see what we got, and see how the actual input and output for that rocker arm is. Now we can go back and forth and try this out. All right, here we go. So we are at ride height, need some tape. Let's figure out how much throw we have. Okay, so we're gonna go all the way up, full compression. Just like a monster truck for this Corvette suspension. We can mark this here. Okay, let's measure that real quick. Oh, it looks like we have ourselves a nice angle coming down. We are at 3 1/4. All right, so we obviously have to get more throw. What I want to know is we don't have enough stroke. So we have to make up for it somewhere. What I do want to see is this. Let's see what angle we're at. I might have to adjust this. moves this coil over here. Now that we have a semi home, we are at 17.9, 18.4, which is going to change if we add more. So I have to make a decision. Do I want to add more to the leverage point, or I want to add more there? We got to come up with almost 2 inches. Let's go play around. Let's play around. I'm going to add more to this. I also want to see what the travel looks like. So the coilover is just starting to move down. All right, so yeah, so the arc radius has to get way bigger up top. So if I add more to the top, I'll add more throw. What's this at ride height? So at ride height, we're at, with this, 101, so I'm at 11 degrees, so I can't really change that. I can shorten that throw up over there. I can shorten the throw up in the bottom on the input side, and that would give me more, but then I would also change this. So if I subtract out of this would dive this angle down, and I like the 10 degrees. That was something that me and Mentor talked about. He liked that. So we're gonna stick with that. So I'm gonna play with this. So we obviously have too much travel here. We also don't have enough stroke. So I'm gonna add more to the top. And by adding more of this, the negative is the rocker is gonna get bigger. But this arc travel here is gonna become larger, and you saw in the video, this thing is starting to travel up and down. So let's go ahead. I'm gonna make one more of these. I'm gonna add an inch, and we're gonna play with that and see what we get. So we're adding 2 inches of throw. So I don't know what that's gonna equate to on the arc circle. We'll go figure that out. So let's make some adjustments, play with this, but this is pretty close. I mean, it's not home, but it's close. All right, so we have the original one, and then as you see, we have a couple of them. So I've been hard at work. I took a little time off the old camera. It took me a while to actually come up with this, and I didn't film it because it took me all my capacity to actually get here, and I want to show you how I got here to help you guys. Let's look at the problem that we had with ours. We knew it was the first one was always going to be off because, well, there's a lot to figure out. So as I laid it over here, what I did to make all these copies, this is the final revision. When we put the original one over it, my straight 90 mark was actually too low. I was measuring for the Heim joint and not thinking of actually building this thing as a perfect 90. So I talked to one of my friends. If you see this design build drive, I love you. And then we kind of came up with a problem that wasn't a true 90. And then from here, I don't know if you guys can see it. When I actually started to figure out where the coilover was going to be, when I started to creep up in length with the output ratio of the coilover, I realized that my output here was not true to how many degrees it was going straight down. So now we're running the coilover at 24 degrees, and it took me building these, incrementally changing them to come up with this. So my output was off, as you see here with the original bowl hole. This was off a couple of degrees, and what happened was for that 24 degrees coming out, so the throw was off originally, just by a few degrees. But really what I had to do was add more length, and this took me forever. I mean, I incrementally went up on here, I took some off of here. Every time I messed with the input of this thing, I always changed the lower control arm pivot point, the Mensor piece, and like it just never was happy. So I had to just keep on adding to it. But the one thing that was good about adding to it was when I added to the top piece coming out, the circle got so big that you'll see it when we bolt it up. Just towards the tail end, you'll see the coilover start to dip. So I'm gonna show you what the tester looks like, then I'm gonna show you what's next. So I'm not gonna lie and be like, oh yeah, we nailed it in the first shot. This took a lot. So we have first rendition, second rendition, third rendition. And finally, the big boy, we got there. It took me like a whole day. Now check this out. All right, so now that this rendition was here, all I did was go back and forth, like I said in the video. I would change my input, I changed my output. Everything that I did with the input never really seemed to get me where I had to go. It was only with the output. And really all I did after a while was I controlled where this was on the semicircle to drive this in. And adding to this, don't mind the bolt, I've actually tested it was all locked in, but just for now we're gonna do for a tester, this is fine. And with all this output, all I had to do was kept on changing it on my semi-arc, and I kept on elongating it to get the stroke it needed. So after I figured out where I was going with it, I computed it and I figured out what my input had to be for my output, and really it was just me dialing it in. So this is the tester right here. So we're gonna go up 2 inches. So right now our ride height, so we should be somewhere in the middle of the coilover, which I believe is 2.75. So we're at 2.75. So 2 inches from there up, we're gonna go 1 inch. 2 inches, right there. Okay, all right, so this is the point where I got really excited and I went a little off the wall. Let's just check this out real quick. So we have 1 inch per travel for the lower control arm to the coilover. So before I send this thing out to the machine shop, I of course have to design it. So I started to design it, I started to put it together, and I went nuts. I went a little nuts, and I want to show you what I did. So check this out. So I took the 2D design, I created a multi-layer piece that I used tab and slots, popped it all together, and I stole the bearings that we used earlier, and I TIG welded on. Now this is not going to be a legitimate piece that we use. The piece that we use is going to be billet, but I wanted to start to wrap my head around the idea of the design. So let's pop this on, let's show you what it's going to be like really when it works. This took me like 4 hours to make because I cut it, polished it, put all the bearings in it, figured out the bearing surfaces of it, made the tab and slot system for no apparent reason because this isn't structural. I was pretty proud of that. So let's see what this thing looks like. So we're going to say goodbye to this bracket. This bracket helped us get there. We're really appreciative of it. We love it. We thank it. Thank it for its service. But for now, we're going to go ahead and get rid of it. Get this thing. After this video's dropped for about a week as I work on the Chevelle, I'm going to see what I like about it, what I don't like about it. This was kind of the first idea I had for a design. What I'm going to do is play and play and play with it until I get something that kind of fits the fascia of the front. The fascia of the front of this car is a little bit more angled and kind of, I don't know, it's kind of strange, right? So I'm trying to find something that matches that. Boom. Then, the last piece of the puzzle. All right, there she is. So, listen, this isn't all the real bolts, this isn't everything, but at least the geometry we know is there. So let's give it a test ride and see what we got. Let's enjoy this moment right here. So let's go back to ride height. Boom, boom. Let's do one more measurement. It's 2.75. We're gonna do the final test here with the real piece. Here we go. You ready? You go down. Whoa. We're gonna go up. She works! She absolutely works. Look at that. Oh my goodness. Probably one of the coolest things I've done so far. That was a lot of work. That was like a lot more than I thought it was gonna be. Guys, if I made it look easy, it was not easy at all, so just know that I was pulling my hair out. It's worth it. That's pretty cool. Drop it like it's hot. You ready? Oh my goodness. That is so epic. See, what I really got to start figuring out now is really how I'm going to mat everything up and how I'm going to do the design and build it, because I'm going to do a bunch of different stuff. I'm not just going to cut it out like this. It's going to be indexed. There's going to be a lot more going on to it. But for now, we made a working prototype. It looks pretty cool. It took a lot of work. I hope it helped you guys out. Hope you guys gained some knowledge from it. This was a struggle bus to edit. And yeah, next up, we're gonna be rocking and rolling on the 1970 Chevelle. We're gonna be building a twin turbo kit for this bad Larry. And then we're gonna get back on the El-Camino and finish up the pushrod suspension, send it out to the machine shop, show the process for that, and then we'll get moving on. And then just keep on building away. Just hammer down every day. Just, here we go. I'm gonna go take a nap. You know, I really hope my videos make you guys giggle, and I hope you guys get something out of it. And if you do, give me a little like and subscribe. Let's try to build up this channel, and we're going to build a little family and go on a little adventure together. Toodaloo!